Okay, so we've got two functions here that we're going to differentiate, and we're going to differentiate them by using the chain rule. Now, you'll notice that the first one is the upper semicircle, okay? And what we're going to be doing is, we already know how to differentiate an upper semicircle, but we're going to be using the fractional index to be able to differentiate it like the proper way, I should say. Okay, so let's start off with A. So for A, we've got y is equal to the square root of 9 minus x squared, okay? So what we're going to do with this is we're going to let u be equal to 9 minus x squared, okay? And so that's going to make du dx equal to it should be minus 2x, not minus x, minus 2x, okay? And so that's going to make y be equal to the square root of u, which is u to the power of a half. So then y is equal to, or dy du, I should say, is equal to a half u to the negative a half, okay? In which case is going to give us 1 over to the square root of u. Okay, so once we've got this, we can now use our chain rule, which is dy dx is equal to dy du times du dx. Okay, so dy du is equal to 1 over 2 root u, and we're going to multiply that by negative 2x. So what it's going to do is going to put a negative 2x on the top. It's going to put the 2 root u on the bottom. Okay, and now we can simplify and resubstitute our u back in. So our u is 9 minus x squared. So minus 2 divided by 2 is just equal to 1. So I get negative x on the top, and on the bottom we get the square root of 9 minus x squared, just as we expected from the other ones. So that is how we differentiate that one. And what I'm going to do is I'm going to put b underneath it, but I'm going to quickly scroll back up and see what it says. And it says 1 over the square root of 1 plus 9x squared. So much trickier, this one. So y is equal to 1 over the square root of x squared plus 9. Oh, sorry. Nope, that wasn't not what it was. It was 1 plus 9x squared. Okay, so first things first is I'm going to rewrite this as y is equal to 1 over 1 plus 9x squared, all to the power of a half. Now, the reason I'm doing that is because we know how to do stuff with this much easier. Okay, so when we've got the square root on the bottom, it makes it too hard. I'm going to rearrange this so the 1 plus 9x squared comes on the top, but if I do that, I need to make the power a negative. Now what we're going to do is we're going to let u be equal to 1 plus 9x squared. So that means that du dx is equal to 9, well, it's going to be, sorry, not 9x squared. It's going to be 2 comes down, we're going to get 18x, okay? And if u is equal to that, then that means that y must be equal to u to the power of negative a half. So that means that dy du, okay, is equal to negative a half u to the power of negative 3 on 2. So dy du is equal to, and this one's going to be negative 1 over 2 lots of, and it's going to be the square root of u to the power of 3, like that. Okay. So now that we've done that, we can work out what dy dx is, and we know that that's dy du times du dx by the time rule, the chain rule. Now dy du is negative 1, so negative 1 over 2, and it's going to be u cubed, times du dx, which is 18x. So the 18x is going to go on top, so we're going to get minus 18x on top, over 2 lots of, okay, the square root of u cubed, so u in this case is 1 plus 9x squared. So 1 plus 9x squared, and that's all going to be cubed on the inside like that. Our last step is then to just simplify it a bit. So dy dx is equal to minus 18 divided by 2 is just negative 9. So negative 9x on, and no 2 there. But we're going to have the square root of 1 plus 9x squared, all cubed underneath like that. So a much trickier one in that case. But again, it's just doing the same stuff that we have been doing, okay? So just differentiating your u, finding your u, and then du dx, then doing y, and then dy du, then putting it all together. Okay, so with that being said, that's going to be the end of this second video, and in the third video, the final video for this little subtopic, we're going to be looking at dividing through by a specific denominator. All right, thank you.